Good morning, class. Today we are going to start our new chapter, increasing and decreasing function. What is strictly increasing function? A function fx is said to be strictly increasing if x2 is greater than x1, implies fx2 is said to be strictly increasing on open interval a comma b if x2 is greater than x1, then fx2 is greater than fx1. For all values of x1 comma x2 which lies between a comma b, that is fx is said to be increasing function, strictly increasing function, if the value of fx is increased with the increase of value of x, that is if it is ox and oy and a function is in the form, this is called strictly increasing, because as we increase the value of x, the value of fx is also increased. Means if it is x1 and it is x2, since it is point x1, it is fx1, value of x1, it is point x2 and it is the value of function at point x2 fx2. Since x2 is greater than x1, then fx2 is greater than fx1. It is fx1 means value of y and it is fx2. As we increase value of x, the fx is also increased, then it is called strictly increasing function. For example, so that the function fx equal 5x plus 4 is strictly increasing function on R. Let two values x1 comma x2 belongs to R such that x2 is greater than x1. Now we have to show that fx2 is greater than fx1. Let given function fx equal 5x plus 4, the value of fx at point x1 is fx1 equal 5x1 plus 4 and value of fx2 is 5x2 plus 4. Since x2 is greater than x1. Now multiply it by 5 both sides. 5x2 is greater than 5x1. Adding 4. And we have, it is the value of fx2 is greater than fx1. Means we have fx2 is greater than fx1. Since x2 is greater than x1 implies fx2 is greater than fx1. Means value of function increase as we increase the value of x, then fx is strictly increasing. Function. Now strictly decreasing function. A function fx is said to be strictly decreasing if strictly decreasing on interval a comma b. If x2 is greater than x1 implies fx2 is less than fx1 for all x1 comma x2 belongs to a comma b. That is, fx is said to be decreasing, strictly decreasing function. If the value of fx is decrease as we increase the value of x. Means if it is ox and oy and it is a function defined on interval a to b, then we have, as we increase the value of x, the value of function is decreases. Means if it is x2, this point is x2 and it is value of fx2, and this point is x1 and it is value of fx1, x1 comma 0 means it is fx1 and it is fx2. Since x2 is greater than x1, because we move to the right side of x-axis, since x2 is greater than x1, we see that fx2 means value of function at x2 is less than value of function at x1. Then this function is called decreasing function. Now, so that the function fx equal minus 7x plus 11 is strictly decreasing function on R. Let x1 comma x2 are two values belong to R such that x2 is greater than x1. Given function fx equal minus 7x plus 11. The value of function at x1 is minus 7x1 plus 11 and the value of function at x2 is minus 7x2 plus 11. Now since x2 is greater than x1, we multiply it by minus 7 on both sides, then inequality reverse means minus 7x2 is less than minus 7x1. Adding 11 both sides, we have minus 7x2 plus 11 is less than minus 7x1 plus 11. It means fx2 is less than fx1. That is fx1 is greater than fx2. Then f is called strictly decreasing function. Monotonic function. A function fx is said to be a function is said to be monotonic in some interval if it is either increasing or in the interval. On interval. Note point. A function fx is said to be neither increasing nor decreasing if fx neither increasing nor decreasing on interval a comma b, if it is somewhere increasing or somewhere decreasing in sub-interval of a comma b. That is, if it is a function defined on a comma b, on interval a comma b, then since it is increasing at this point a1 and decreasing at this point a2 and again increasing at this point a3, further decreasing at a4, then it is neither increasing nor decreasing, neither increasing nor decreasing in whole interval a comma b. Then the function is said to be neither increasing nor decreasing. If it is somewhere increasing or somewhere decreasing in subinterval a1 comma a2 or a2 comma a3 or a3 comma 4 of interval a comma b. Necessary condition: if fx is continuous on a comma b and differentiable on open interval a comma b, then fx is said to be strictly increasing on a comma b if f dash x is greater than 0 for all x belongs to a comma b, and fx is said to be strictly decreasing if f dash x is less than 0 for all x belongs to a comma b. And means a function is said to be strictly increasing if f dash x is greater than 0, and a function fx is said to be strictly decreasing if f dash x is less than 0 for all values of x lying between a comma b.